All right, welcome back. And this is part 4 of our series about building a real-world Clojure application from scratch. And things are getting real today. So we are going to add a persistence layer finally. So we're going to use a Postgres database, and we will configure our application to connect to the database. So now on your screen you can see the dependencies that we need to add for today's changes. So the main library we are going to use is this next.jdbc, which is kind of standard in Clojure world to work with databases. And also we need a driver, this one, PostgreSQL. It is specific for the database that we're going to use, but as we're going to use Postgres, we need this one. If we go to the documentation, it is right at the top. So if you prefer other database like MySQL or Microsoft or something else, there are different drivers specified on this page. So pick one of those. Going back, for our test environment, I suggest we're going to use TestContainers, which is a pretty good tool from that supports Java and multiple other languages. So basically, the idea is that you can control your real containers in Docker with your real infrastructure from your test code, and we'll see that in a second. If you want to learn more about TestContainers, just go to their official website and read about every language that's supported or every container that's available. If we going to module and then we scroll and go to relational databases, we're interested in PostgreSQL, and there is a simple example how that is used. But really, this tag is just a Docker tag for the container image. And with these 2 lines of code, you can start your container from code, and you have useful API available in the code to get your connection params and all that stuff. But yeah, no worries, we will see it in a sec. And the final dependency for the later for today is HikariCP, which is a database connection pool. So in production, we want some kind of connection pool, not creating connections when they need. So yeah, we're going to use this HikariCP, and it's quite popular. All right. The only thing I've done is just added these dependencies and created a simple test. It's a new folder here called persistence, just to split our test from component and unit. So a persistence test is basically focusing on some logic to communicate with the database itself. So going to our namespace, we have this simple test, and I prepared a small snippet here. So let me just copy this one into our namespace, and we want these 2 lines. Oops. 2 lines here, and here we go. So let's ignore this block for now and see what we're doing. So this PostgreSQL container is a part of this TestContainers library. And as I said, after that, we just specify a Docker tag for the Postgres. And when we run this, it will create a database container. And then we start it before we run the test. And in the finally block, we stop the container. So let's, for example, do a simple assertion here for now. It's like 1-1. And we also, for example, want to block our thread for a while so we have more time to investigate. Let's say 5 seconds. Reloading the namespace and running it. And now if I run docker ps, we see that our test is actually starting container. So one is, this one is basically some orchestration container, but it's also starting our Postgres as well. And as you can see that there are no failures, so our test is passing. So we can remove this now And if we go back and uncomment this, we can get a JDBC URL from our test container once it's started. Just to show you how it looks, just compare it to an empty string. And if we run that again, you can see it's creating a real, it's starting a container on a random port, and then we have this JDBC URL to connect. But also now our main test is passing, and what we're doing is basically creating a data source. Then we pass the connection params. So we get JDBC URL from a test container, username and password, and then we have a data source, and this is JDBC/execute is how we, the simplest possible way is to execute the database query. And as we don't have any tables, nothing in the database, I just decided we can just select one and name it as R, like as a result, and we compare that the result is this R1. And as the test is passing, we see that it is working. So yeah, congratulations, we have the first persistence test, but it's not connected to our system yet, so we don't start our database component as a part of the system. So let's fix that. To do that, let's go to our core namespace, and we want to add a new component here. Let's call it data source, right? And this library, next.jdbc, provides a way to create a component as a function. So if you search for component, you will see this block, and we're interested in this line. Actually, only this, right? So we're going here and insert it here. We need to import stuff, and then this db spec is just a plain map, so you can configure it with db type, db name, username, and password. But also instead of this params here, we want to specify, we can specify the JDBC URL. So we'll stick with that option. And we need to get it from our config. So let's say config db spec, right? After that, we're going to this development where we pass our configuration for development, and let's say db spec here, right? Then we have JDBC URL, and I actually have it somewhere stored here. This one. Yeah, so JDBC URL will be this one, and username will be RVCA for real world Clojure application, and same for the password. Okay, but as I said, the test containers are just in the test environment. Now we want to run our application from the REPL. So I suggest we create a real database and start it. The easy way to create your local environment is to use Docker Compose, and that's what we're going to do. So let's create a new file in the root called Docker Compose YAML, and we insert this snippet. So it basically says start these services. This is the service name, which will be a database. Then we specify the same image. Then we map our ports, and then we configure some properties. Basically, we're setting the user, like the database master user, to this name, and same for the password, and same for the database. So cool. Now we can run Docker Compose up. Docker Compose up -d to start in detached mode, and we have Docker Compose ps, and we see that our database is started. If you are using cursive, let me grab our dev config. So if you using IntelliJ Ultimate, you basically have an option to configure your data sources here. If you're using different editor, there are free options to work with databases, so you can download them. So if we go to the new data source, we can insert our URL here, and our user will be irvca, and same for the password. And then we can test our connection. It's green, good, apply. And now we are in our database session, so we can select one, for example, execute it, it's working, and also maybe like show server version. Yeah, so we connected to our real database, and we pass this DB spec to our system that we start from the REPL. So let's go to core namespace again. We now have this component as well. So we want to pass it to our pedestal component as a dependency. So we have access to the database from our HTTP handlers. So we can now create some logic there with the database. So we passed it in our dependency list. Then we want to specify it here as a data source. If you remember from the previous sessions, we have this interceptor to inject dependencies. So everything that's specified in the component dependencies will be passed into the context of our interceptor, our requests. So what we want to do is to build a new endpoint here. Let's call it info, and we will print our database information here. So it will be get, and let's call it info handler, root name info, and let's pick this one as an example, and we can call this info handler, and same here. Cool. So as you see, we already destructuring these dependencies from the context, right? So we want to do one more destructuring, so we can do keys, and then we say data source from dependencies. So this data source will be passed from the component graph. And after that, let's copy our response from the grid handler, this one. And let's put it in the response. So let's restart our development session. It is started, and then if we go here, let's just call this info endpoint. So we still have this hello world. Let's say, for example, we want database server version, and we'll print version here. Let's refresh. Yeah, we have it here now. And now, as we have access to this data source here, let's actually do a call to the database and execute a SQL statement. So what we can try is I got this thing here. So let's say db response, right? And it will be, we're using this jdbc /execute to execute our SQL statement, and then we want to call data source. By calling this data source, it will create a connection, get a connection from the pool. And after that, this is our simple SQL statement. So for now, let's just print this. Print, reload, restart. Yeah, and you see we get this map back from DB. So now I just suggest we just concatenate it to our string. So it will be server version from DB response, right? Now we can remove this line, reload once again. Yeah, and this is our response. So we now hitting database from our HTTP handler, which is nice. And the final thing for today is actually let's create a component test for that. Let's copy this and let's name it as info handler test. Then we want it info handler test here. Let's remove everything. And from our persistence test, we actually want to copy this bit to create database. So for now, as you can see, it's quite a lot copy pasting, but I'm just keeping the balance between doing it properly and easy to follow. So ideally, we want to wrap everything in some functions, helper functions, or like saying even some macros for database containers, or there is an option to create text fixtures. We will definitely look into those options later, but for now, it's not that bad just to copy paste a bit. So let's say now we have this test and it is info handler test. Handler test. So we have the database, and then we want try catch around this. We want to start our database container, and at the end we want finally block, and we want to stop it, so we don't have any Docker containers hanging. Cool. And now we want to pass DB spec here, and we're interested in JDBC URL, username and password. So let's copy that from our persistence test as well. So it will be here, right? That. The only thing it's called username. Russ. Cool. And here we want a URL for info, right? And let's try to run that. Okay, so let's debug. Actually, now in one of the previous series, I added an extra component and it's missing some properties here. So we actually want HTMX here and server port, get free port. I think that will work. Yeah. It's not related to the changes for this video. It's basically we starting this separate component as well, and it was failing because this config was missing. But yeah, let's see what we have. We have a test mismatch, but basically that's because the assertion is not correct. So the only thing is change this assertion, and we can restart. And voila, we have a component test that involves the database query as well. All right, so I think that's it for today. It was still a lot that we covered. And in the next series, we finally will look into creating a real logic in the database. So we have these to-do handlers that we have. So we'll build some tables to store information in the database. We'll create some migrations with the flyway, and basically we'll have a new set of APIs that will do a real work under the hood with the database. And also we'll take a look in HoneySQL and HackSQL as good options to build our more complex SQL queries. But yeah, that's it for today anyway. Hope these series are helpful for you guys. If so, please like, subscribe, and leave a comment, and that really helps. Thanks for watching. Have a good one, and see you in the next video. Bye-bye.